Jackrabbits are desert dwellers, so they have to be able to maintain homeostatic temperatures in extreme climates. Their characteristic ears help regulate temperature very effectively.
We were inspired not only by jackrabbits, but also by research conducted by Richard Hill and James Vett. Their research was based on past known information about jackrabbits, and they tested the hypothesis that they regulate temperature based on the difference between atmospheric and body temperature. The researchers used infrared radiography and temperature cabinets to test 3 female jackrabbits. They discovered that jackrabbit blood vessels vasodilate when their body temperature is higher than the atmospheric temperature. Conversely, their blood vessels constrict when their body temperature is lower. At surface temperature, blood flow is minimal and consistent. Essentially, within 15 degrees of normal core body temperature, jackrabbit blood vessels will dilate, and anything beyond that, the vessels will constrict.
Our jacket, TempTemp, attempts to mimic this incredible temperature regulating mechanism. It detects the user's core body temperature using a detector in the chest pocket and heats or cools water accordingly. We used water because it has a high specific heat, so it will retain the desired temperature. The water utilizes gravity to flow down the jacket through the vessels and is then pumped back up through larger vessels on the sides of the body and arms. The heating, cooling, and power-generating mechanisms are performed with thermoelectric semiconductors on the sides of the jacket. The jacket has 3 core layers surrounded by lightweight fabric. First is an insulator on the outside of the jacket to prevent unwanted heat loss. Under the layer is the main hexagonal grid of vessels that carry water throughout the jacket. The vessels are made of a pliable resin that can constrict or dilate based on the volume of water flow, which is controlled by the same pumps. These vessels are then connected to a layer of non-flammable porous material that will respond to the dilations and constrictions in the vessels, controlling the distance of heat conductance.
While the jackrabbit's natural habitat is the arid desert, our jacket would be tailored for bedside usage in hospitals, so our jacket's environment would be our patient's fluctuating skin temperature. While the environments differ, the system behavior of homeothermic regulation is the same. Inspired by the millimeter or micrometer wide blood vessels of rabbit ears, we would create millimeter or centimeter wide compliant pipes that would form a hexagonal fused network. The original research looked at how blood vessels influence rabbit ear temperatures, but we would want to influence the temperature of the entire upper body with the surface area of our jacket. We believe we can achieve this scaling with the same mechanism of the jackrabbit. When the body temperature becomes too hot, the hexagonal vessels will dilate and circulate cooler water. When the body temperature is too low, the vessels will constrict and circulate warmer water. While jackrabbits passively monitor their body temperature, we would actively monitor it with a sensor in our jacket's chest pocket. In terms of performance, our demands are similar to the jackrabbit. We will want our jacket to be fast-acting, reactive, and capable of keeping our patients within a small temperature range. One advantage our design has over nature is that we do not have to circulate blood and all the nutrients it carries. We can simply use water and make use of its specific heat capacity. Also, our vessels do not have to be porous enough for diffusion. The fluid in our design can stay in a closed-loop system that makes use of heat diffusion across pipe surface area and padding. Our structure is also more complex than our natural counterpart. We have stabilizing cylinders that give shape to the hexagonal network and keep it sandwiched between fabric layers.
Moving forward, we hope to collaborate with professionals in a wide range of fields. We will collaborate with Jennifer Lewis, a material scientist at V's Institute, to help us work with 3D printing compliant parts for our vessel network. We also hope to collaborate with physicists to find a way to expel excess heat. And in the future, we can work with a fashion designer to make her jacket aesthetically desirable.
When our bodies aren't able to function properly, we can call on nature to help us. This is a jackrabbit. Its ears are the inspiration for TempTemp, the first ever self-circulating jacket. Jackrabbits circulate blood through their ears as an effective temperature regulating mechanism.
TempTemp uses the same concept to circulate water through a network of vessels contained in the jacket. If you are unable to maintain normal body temperatures, TempTemp can do it for you.
This means helping people with issues ranging from fever-induced infections in hospitals to hypothermia when conducting research in extreme environments and everything in between. TempTemp, inspired by nature.